Good morning, grade 10s. What we're doing here is we're going to take a look at Unit 5, Lesson 2, which is vertex form. Before we really dig into the lesson, what we're going to do is review Lesson 1, okay? And we're going to do this warm-up by graphing the equation y equals x squared. We call that the standard parabola, okay? And then we're going to state the key features. So all we're going to do to graph it is we're going to come up with a table of values, which is given to you on your note. By the way, your note, you should be in the student package, page 6 to 7, and then your homework is going to be page 8 to 10 in that package, okay? So just an FYI. So let's have page 6 open, and you should see this chart here that will represent a table of values. And all we're going to do is we're going to take the x values in the table of values, and what we're going to do is we are going to plug them into this equation. So you're going to begin, I'm going to pull my calculator out here so you can see me do at least the first one, okay? You have a -3. So what you're going to do is you're going to say y equals -3 squared. When you type in your calculator, you have to make sure, because you're squaring a negative number, that you put it in brackets before you square. Okay? And so we should get 9. Okay? Then what we're going to do is we're going to take a look at -2. Okay? And that, work it out the same in your calculator, you'll get 4. -1, you'll get 1. 0 will be 0. X equals 1 will be 1. We get 4 again, and we get 9. And now what we're going to do is we're going to take this information, okay, and we're going to graph it. So our first point is -3, 9. So that's about right here. Actually, looks like I didn't space that out very well. -3, 9. Okay. Our second point is -2, 4. Our third point is -1, 1. Our fourth, 0, 0. Our fifth is 1, 1. Then we have 2 and 4. And then we have 3 and 9. Okay. And then we're just going to do our best to draw a smooth parabola through the points that we've drawn, okay? Now we will state our various key features. What is our vertex here? Well, our vertex is right here, and the coordinates would be 0, 0, okay? What's our axis of symmetry? Well, it's going to be x equals whatever x value mirrors this parabola, and in this case, the axis of symmetry is the y-axis, which means x is equal to 0. It's always the x value in your vertex, okay? Does it open up or down? Opens up because we can see the arrows pointing up, okay? Is it a max or a min? Okay, well, it's a min. And what's the value? The min value is actually going to be 0. Because that's the y value that it's at its minimum. Okay. In this case, what's the y-intercept? Well, it's 0, 0. That's where it intercepts the y-axis. And what's our x-intercept? There's only 1, and it's also 0, 0. Okay. So that's just a little warm-up. It actually only took barely half a page on the note, but I just spread it out here because my writing's a little bit bigger, and I was doing it on graph paper. Okay. So what we can do now is we're still on the same page. I'm going to flip this page over, but we're still on page 8. Sorry, we're still on page 6 of our note. And what we'll see next is there's a chart. And the chart says there's 3 different forms of the equation for a parabola. There's vertex form, there's standard form, and there's factored form. And I want you to take a good look at that chart and look at the different examples. But what I want to talk about is what's the point of these 3 different forms, okay? Well, vertex form, that's the form that we use because it gives us the vertex, okay? So for example, they give us the equation here, y equals x plus 3 squared minus 4, okay? And the vertex is going to be -3, -4. Now, where did I get that from? Well, the x value is the same as this value inside the brackets with the opposite sign, Okay, brackets lie. So that's something you're going to remember here. When we see the brackets, it's positive 3 in the brackets. When we write the vertex down, it's going to be negative 3 because brackets lie. Okay, and then here, the negative 4, well, that just came from this negative 4 at the end. Okay. Now, let's take a look at standard form. What's standard form good for? Well, standard form is good for finding the y-intercept. And the example that they give us is y equals x squared plus 6x plus 5. And what we find is that our y-intercept is 0, 5. Why? Because 5 is the last number there. So we're going to say our y-intercept is 0, 5. Okay? And the last form is factored form. And the example that we have is y equals x plus 5 times times x plus 1. And what we find here is, what are our x-intercepts and our zeros? Well, we get them out of these two brackets, and we get negative 5, 0, and negative 1, 0. See how it's positive 5 and positive 1? Well, brackets lie, so we take the negative values. Okay? Now here's the important asterisk here, and it's written in your note. All three of these equations are the same parabola. We just write them in 3 different forms. So for now, what our exercise is going to be is saying, let's look at each of these 4 examples that are written here in the book, in your student note on page 6, and describe which form the quadratics are in. So the first one is y equals x minus 3, x plus 2. What form is that in? Well, it's got the 2 sets of brackets. That's indicative of factored form. So we'll say that's factored form. Our next example is 16x squared plus 12x minus 41. What form is that in? Well, look at the table right above. Which format does that match? Okay, it's got no brackets, so that points us to standard form. So we'll say standard form there. C is y equals 11 times x minus 17 times x plus 5. What form is that? Well, we're going to say that since there's 2 sets of brackets here, that best matches factored form. So we'll say it's factored form. And the last example here is y equals negative 3 x plus 2 squared minus 8. Which form is that? Well, notice there's 1 set of brackets, and that set of brackets is squared. That tells us that it's vertex form. Notice here in vertex form, we have 1 set of brackets, and it's squared. So that clues us in. Oh, that must be vertex form. Okay. Now, if you move on to page 7 of your student package of notes, there's a little bit written about vertex form. So I'm going to read it. It should be out in front of you, even if it's not in this video. It says vertex form is in the format y equals a times x minus h squared plus k. Okay? The coordinates of the vertex are always hk. H is the x coordinate, k is the y coordinate. Notice how it's x minus h. That's why we're always going to take the opposite sign of whatever is in that set of brackets. So see how it says minus h in the set of brackets? Well, h is the x coordinate. If it were plus h, we would say minus h is the x coordinate. Okay? When a is positive, the parabola opens up. When a is negative, the parabola opens down. And if we want to find the y-intercept, we will let x equal 0 and solve for y. Okay? So what I want to do now is I want to move to page 8, and we're going to put some of this stuff into practice. Now, page 8 to 10 is your homework, but we're going to do one of these problems as a sample problem, and then the remainder will be your homework to do on your own. Okay? So we will begin with practice question number 1 on page 8 of your student package of notes. And it should be the equation y equals x plus 3 squared minus 4. Okay? And what we're given here is we're given a chart that has these key features that we want out of this graph. And then we're also given a Cartesian plane to graph. What we're actually going to do is we're going to do our best to fill out the chart first, and then we will graph. Okay, and then we will graph. Okay, so we'll take a look at this first example. What is the vertex? Well, we're going to look at this equation and we're going to highlight those two digits here that tell us something about the vertex. So the plus 3 and the minus 4 tells us something about the vertex, but you have to remember, brackets lie. Okay, so our vertex is going to be -3, -4. Okay, and then the axis of symmetry is always the x value in our vertex. So we'll say x equals, and the x value in my vertex is -3. So we'll say it's -3. Okay. Now, does this open up or down? If we look out in front, there's no negative sign here. And if there's no negative sign, that means it opens up. If there was something in front of this bracket and it was negative, that would mean it opens down. Okay? That would mean it opens down. Okay? Since it opens up, it will have a min, and the minimum value is going to be the y value of the vertex. So we'll take that -4 and we'll bring it down there. Okay? And the y-intercept, well, we know how to solve for that. What we'll do is we'll just plug in 0 as x and we'll solve. So we'll say y equals x plus 3 squared minus 4, x equals 0. Okay? So that means we'll say y equals 0 plus 3 squared minus 4. Y equals 3 squared minus 4. Y equals 9 minus 4. Y equals 5. And that means our y-intercept is going to be 0, 5. Okay, now your homework says to calculate the x-intercepts. We're not going to worry about that right now. We're not going to worry about x-intercepts from this format at this point in time. We're just going to do our best to sketch the graph based on the information that we have. Okay, so before we graph that, there are two questions underneath. It says, how did you know the direction of the opening by looking at the equation only? We'll say A is positive. In other words, in front of the brackets is positive. Okay. How do you know the vertex of the parabola? Well, we know the h and k value. That's the 3 and the -4. Okay. So now we can graph. Our vertex is -3, -4. So -3, -4, we'll mark that right there. Okay, and our y-intercept is 0, 5. Okay, and our axis of symmetry is y equals -3. So what we'll do is we're just going to draw that axis of symmetry on here with a dotted line. It's actually going to help us a lot. Because I know if I'm 3 spaces away from this axis of symmetry here at this y value, then I know that the mirror image is going to have another point right here. So now that's enough for us to begin to sketch. Now we are missing the x-intercepts. We're not sure of those. Okay, but that's okay because we don't need them for today's lesson. And so that's all you have to do to solve that problem, is now connect the dots with a nice little smooth parabola. And because I drew a little bit of sketching on there, I'm just going to highlight the actual parabola itself. Okay, so that's good enough for a solution there. Now what I'm going to do is I'm going to have you complete the remainder of the practice questions from page 8 to 10. I will post solutions on the LMS So you'll find them there, as well as the student copy of the notes and the filled in copy, the master copy of the notes. Okay? Until next time, please stay healthy, please stay safe, take care, bye-bye.